Here is the object we are asked to draw. We are asked to find the true inclination between the blue and the red surface. What we can also see here is the plan, elevation, and end view. And just to give an overall view of the object is the isometric view. What we can notice from these three principal views is that we are unable to see the true inclination between the surface, the blue surface, and the red surface. So we are going to have to take an auxiliary of the object, which means that we are going to have to move around until we see the blue and the red surface as lines. And this is exactly what I'm doing here. And now we are able to see the true inclination between the blue and the red surface here. What we will also notice is that the circle that was here has now turned into an ellipse. This is because we are now looking at the circle not straight on but at an angle. So the circle turns into an ellipse. When we're drawing our auxiliary, we will have to remember this. Now, this is the question we are going to draw. It is find the true inclination between the red and the blue surface, as shown here in the plan and elevation. Now to see this, we must see the two surfaces as lines. So to do this, we must look directly into the blue surface, which we do here. We then create a new x1, y1 line, and this is the new ground line. We can then mark off our heights, h1 and h2, mark them off in our auxiliary elevation, and draw them in there. Now with this and the projection lines, we're able to find points on our auxiliary projection to get the true inclination of the surface. This is the true inclination of the surface marked in here. Now, part B of the question says we must draw the full object in the auxiliary projection. So, to do this, we will deal with the base first. So, we will project the rest of the lines up. We're still able to use h1 and h2 because the heights remain the same. Find our points and draw it in. This is the bottom base fully drawn in. Now we want to deal with the curved surface here. So to do that, we must remember that when we draw it in an auxiliary, that the circle becomes elliptical. So to do this, we must put in 30 and 60 degree lines which divide the circle up into equal parts. We then bring these parts down to the plane and project them up to the auxiliary elevation. We must do the exact same thing again, just with different heights. So we have h3, and we're able to mark h3 off on the auxiliary elevation. Then with that, and the projection lines, we're able to find 2 points on the circle. We do the same then for our height line h4, mark them off in our auxiliary projection, draw the line across, find the projection lines, and mark in the other 2 points. We do that again with the last 2 heights, bring our heights into the auxiliary projection, bring the heights across, and mark them off on the projection lines. We are then able to freehand sketch in the curve. This is only the front part of the curve. Now we must do the second half of the curve. When we project the lines up again, we can use the same heights, so we just mark off the points again. Then we freehand in the curve and draw in the final part, which is just connecting the two circles, and this is our auxiliary elevation fully done. We can also see that the back of the circle is hidden because we're not able to see this, and we can see that it is not a circle anymore, it is now an ellipse.